Okay friends, today we will solve some problems on the compression members, and as we did for the tension members, we have the set procedure for the compression members also. So initially we will solve some basic problems, and then one big problem will be on the design of the compression member. So let's start with the problem number 5.1. I will read out this problem for you guys. So problem says a column consisting of SC140 at the rate of 33.3 kgf per meter has an unsupported length of 4 meter period. It is effectively held in position and restrained against rotation at one end and at the other end, restrained against rotation but not held in a position period. Determine the axial load this column may carry if the steel conforms to IS 226-1975 period. So basically we have to carry out the compression load carried by this particular member, steel channel 140 at the rate of 33.3 kgf per meter. So let's start. First of all, we have to find out the yield strength of the steel, that is Fy. So this will be equal to 250 Newton per millimeter, and this is for the steel that conforms to IS 226. So it is given in the problem. So if it is not given, value is not given, generally in the exam it will be given, so you don't have to worry about this part. So Fy is here, our yield strength of the steel is 250 Newton per millimeter square. Then we have to get the properties for the SC, that is channel used as a compression member at the rate of 33.3 kgf per meter. So 33.3 is the unit weight of that, or unit mass of that particular channel, kg force per meter length, and this indicates the name of that channel. So if you don't find the properties in the steel table, just Google it and try to find it online. Otherwise, if such kind of section is there whose properties are not in the steel table, definitely it will be given in the exam. So properties for this particular SC140, so area of this section is 4.24 into 10 raised to 3 millimeter square. Then Rx, that is radius of gyration for x direction, 58.9 millimeter. Ry, that is radius of gyration in y direction, millimeter. So we need the minimum of 2, so definitely this is the minimum, 32.1. so this is our minimum. Why we need our minimum? To find the lambda max, right? So lambda max is equal to L divided by R minimum. So we will use that value here, but we still don't know about this small l. The small is effective length. Small l, how will you find a small l? So from the table 5.2, so for given type of the axial loading for the compression member from table 5.2, small l will be equal to 1.2 times of unsupported length. Unsupported length is 4, so effective length in this case will be 4.8 meters. So we have to just plug this value and our minimum value to get lambda max. So lambda max in this case will be equal to 4.8 meter, and our minimum, that is 3.21 centimeter or 32.1 millimeter. So this is in centimeter, this is in meter, so make it in centimeter. So now both the ratios or the units are same, so you will get lambda max equal to 149.53. So why we are determining lambda max? Our ultimate aim is to find out sigma AC, that is permissible compression stress for this particular compression member. So that is our aim, and for this we have to use the table 5.1. So here we know that lambda is lying between, because our lambda max is equal to 149.53, so it is lying between 140 value and 150 value, right? In the table, if you see the table, it will be clear. And we have yield stress Fy value, that is 250. So using these two values, this value, but we need it for 49.53. So we need to interpolate. So sigma AC will be equal to 51 minus 45. So this is the value for 140 and this is the value for 150. So this is the difference. So this will give us per unit difference, that is per unit increment from 140 to 150, but our value is 149.53, so we need to multiply it by 9.53, right? So our sigma AC, that is permissible compression stress, will come to this value 45.28 megapascal. Remember that megapascal is equal to Newton per millimeter square, or that is same, right? So now it will be easy to find out the allowable compressive stress or compressive load resisted. You can say anything, resisted or carried by this section or compression member, right? This section of the compression member. So what will be that? So that will be equal to, as simple, if we have the uh, trace, right? We already calculated allowable trace and then area, right? So allowable trace is 45.28 megapascal. You know that Newton per millimeter square. Area we need in millimeter. So this is 4.24 into 10 raised to 3. So this come from properties. So finally, and one more thing, if you want to make it in, because this is millimeter square, so this will cancel out and only remain will be Newton. So divided by 1000 you will get in kilonewton. So finally this value will come to 191.98, okay, kilonewton. So maximum compressive force resisted by this compression member or this particular section of the compression member will be 191.98 kilonewton. That's it. Thank you.